Alright, for 2C, a couple things you might want to know are the equations of a line. We have two that are very useful. We have point slope form, which is y minus y1 equals m times x minus x1. And we also have the slope intercept form of a line. Very useful. Helpful for doing things like this. Also, if you just wanted to know, the slope of a line is y1 minus y2 over, I'm sorry, we really should do it the other way. x2, y2 minus y1 over x2 minus x1, just to align with the star geometry materials that we will be using on the test. So on the exam, you guys will have the star geometry materials that has that has all these formulas on it for you already. So you will have that available. You won't have to worry about memorizing these formulas, except for one you might want to know is no, slope is on there. They're all on there, so you actually need those. Anyways, for these, we just want to find the equation of a line that passes through the point -1, 2, and has a slope parallel to this line. So this line has a slope of 3. If we want it to be parallel, we might want to remember, this is something you might want to remember though, if we want our slopes to be parallel to each other, and we want them to be the same. So, lines with the same slope would be parallel, right? If I drew a line and another line, if they are parallel, then if they're never going to touch, these lines are never going to touch, then as far as this line goes in the right, they have to go the same exact distance up. Their rate of change has to be the exact same, otherwise they would eventually touch somewhere, right? Even if they were slightly off. So since this guy is in y equals mx plus b form, we know that m corresponds to the slope, and so the slope must be 3. So we want our m to be 3. Now we just have to write the equation of a line that has an m of 3 and passes through this point. Well, fortunately for us, the point slope form, if you have a point and slope, we can give to this equation to make us a line that just does just that. So y minus y1 is 2 equals m times x minus x1, which is really plus 1 minus a negative 1. And there, and our m should be 3. So maybe I'll keep my 3 red here. And there you go. This is it. This is the equation of a line. Bonus points if you simplify to y equals mx plus b form so that it's easy to graph, but you don't have to for this problem. It just wants the equation of a line, and that's sufficient. So, to find the equation of a line perpendicular to this guy, same thing. We want to find the equation of a line, except it's perpendicular to this line given. So this guy's in y equals mx plus b form. M corresponding to the slope, so the slope is 3/5, negative 3/5. So if we wanted to find the perpendicular slope to that, we could come up here. Let me maybe write this down too. If we want slopes to be perpendicular, then we want them to be the opposite reciprocal of the other. So I like to think of it like the negative flip. So you're going to flip these fractions over and then make them negative. So in this case, if I was going to flip, that would be negative 5/3. And then I want to make it negative. So I'm making negative 5/3 negative, which is positive 5/3. All right, there's the slope of the line I want. Now I just need an equation, and that's perpendicular to this one. Okay, well, it doesn't have to pass through any point. Notice I don't need it to pass through a point like I did on this problem. All I need is an equation of a line that has the slope. So it might be easier to use slope intercept and then just pick any intercept. So I'm going to say y equals, from my slope is going to be 5/3 times x. There we go. And then just from my y intercept, I'm just going to pick the same one I had here. No big deal. I could pick anything. I could pick whatever I wanted. I could pick 3. I could pick 10. Sorry, I could pick 10. I could pick 214. It doesn't really matter. As long as this is the opposite reciprocal of this line has to be parallel. In fact, I could even pick like pi squared. E to the I theta. Anything you wanted to pick for this number. It could be anything in the world. I guess I should say e to the I pi instead of e to the I theta. But, it could be any number. So, similarly, if we continued on, let's see. To name any line perpendicular to one that passes through this point and this point. So first of all, we need to know a line that passes through those points, or at least we need to know the slope so we can find a line perpendicular to that one. So the slope of this line is, it would be y2 minus y1, that's 5, minus 1 over x2 minus x1, 4 minus 3, and we get that it is 4. So on the bottom it'd be 1, and it simplifies to 4. Now, we want the opposite flip of this guy because we want it to be perpendicular. We want the slope of our actual line to be perpendicular. So we're going to flip it to 1/4, because really it'd be 4 over 1, right? And we're going to flip it to 1/4 and make it negative to negative 1/4. Now this is our new line. Now we just want to name a line. So we're just going to make an equation, y equals negative 1/4 x. All right. And now it just wants us to name a line that's perpendicular to the one that passes through these points. So our line doesn't necessarily need to pass through these points. So I'm just going to pick, it could, it doesn't matter. If it does, if you wanted to do that way, you could use point slope form here, pick one of those points and make the equation that way. I'm just going to use y equals minus 1/4 x, and then similar to our last problem, I'm just going to pick a random intercept, like, I don't know, plus 3. 3 is a good number. Actually, let's do 7. 7's a better number. Plus 7. So this line is perpendicular, guaranteed, because its slope is the opposite reciprocal of the slope of this line, which you found to be 4. And that's sufficient for the answer. For the last one, we just want to write the equation of a line that passes through this point and this point. Well, to write a line, we either need a point and a slope, or we need a slope and an intercept. Since a point is already given to us, since 2 points, or well, I should say, since 2 points are given to us, we could find the slope. And slope is needed for both of these. Sorry, I meant to circle slope there. Slope is needed for both of these, so we can find the slope. We should probably do that first. Alright, so m equals, and then I'm going to have negative 10, that's this value, minus y1, which is minus a negative 2. Never forget those parentheses. Look how straight that fraction bar is, dude. I did that free-handed. Alright, then negative 5 minus 1. Negative 5 minus a negative 1, I should say, is equal to 10 minus negative 2 is 10 plus 2, which is 8, and then negative 5 minus a negative 1 is negative 5 plus 1, which is 4, and 8 over 4 is, of course, 2. So there's the slope, and now we just want to write an equation of a line that passes through this point and this point. So I could pick either of these points. Let me erase all the clutter I have here. I could pick either of these points. I'm just going to pick this point because it's the easiest, less numbers. You could pick either point, it doesn't really matter. I'm going to come back up here. Now that I have a point and a slope, I can use point slope down here to make my equation. Y minus y1, which we said was negative 2, that's coming from here, equals m, and we just found m to be 2 times x minus x1, which is here, minus a negative 1. Alright, and of course this equation is the same as, and usually in mathematics we use like a bold arrow to say that this is our next step, but you don't have to if you don't want to. And this will be y plus 2, as long as I know what you mean, no big deal. And then 2, and x plus 1. Now we just want an equation. It doesn't say in any particular form, so this is a sufficient equation, but if you're going to graphic, for example, bonus points, to simplify to y equals mx plus b form. And to do that, you would just, totally lost my word, distribute my 2 out over to these guys and then subtract 2 from both sides. That'd be your second step. So in 2 quick steps, you could be done with that one.